This is the final review video of my 3D printer project for mechatronics of winter semester 2021. So this is the 3D printer. As you can see, all the parts are now made out of 3D printed plastic with the belt tensioners on the X and Y axis over here. So all the axes ride on these stainless steel rods, smooth rods. These are 8mm stainless steel rods. The Z axis runs on this 8mm 1.25 pitch threaded rod, M8 size, and the X and Y axis runs on GT2 belts, which are driven by their stepper motors respectively, here and there. So the whole thing is controlled by this Ramps Arduino combo. There's an Arduino Mega beneath it, and runs on this pololu A4988 stepper motor drivers. There are 4 of them. This all runs off of this 12 volts 30 amps regulated SMPS, as you can see. So the printer runs Marlin currently. This printer is using PLA right now. PLA is fed to the printer using this extruder. This is a Mark 8 extruder, and the stepper motor has been geared 1:3 to increase the torque. The hot end is a E3D V6 hot end with a 0.4mm nozzle underneath, as you can see. So the bed dimensions are 280 by 300, that is 300 in length and 280 in width. So now we can see the SD card and LCD. The SD card is read by the Arduino using SPI, and the LCD is controlled using I2C. There's a reset switch, so if you click it, the printer will stop immediately. There's a buzzer, and there's a rotary encoder with a push button. So from here you can select which file to print. As you can see, the YACS is there. The printer is now heating up. You can see the PID control is working, so the LED shows when the heater is on, so it is flashing because of the PID control. As soon as the set temperature of 225 degrees is reached, the printer will start printing. So it has just completed its homing sequence. The limit switches are here, one underneath here and one over here. As you can see, it has started its priming sequence now, and will start printing now. As you can see, the printer has started printing. This stuff you can see on the bed is actually just Fevi-stick, which is used to make the print stick to the bed a bit better, because the bed is not yet heated, but we can attach a heating element to it later. The bed can be leveled by these screw arrangement, like you can see, this is a small rack and screw arrangement. About the motors, these are actually minbea stepper motors, as we have talked about. Because they are overvolted a bit, they tend to overheat a lot, so I put heat sink on them. As you can see, most of the motors have heat sinks on them. And this just a PC cooling fan to provide extra cooling. The Z-axis motors don't have heat sinks on them because they are set to get disabled after 120 seconds of idling, because the Z-axis tends to stay idle quite a lot, so they don't have the heating problem. All the parts on this printer were made on the printer itself, like all these PLA parts were made on this printer itself. This printer started with the wooden version in the review 1, and now it has been taken to its final, that is the review 3. All the parts are according to the CAD model, and as you can see, it is printing. The prints are all sliced in Prusa slicer, which you can see right now. I will show the YACS cube. So this is the Prusa slicer
2.3.1. So now I'll just import the YACS right here. You can see this is the YACS, and we can scale it down here about 50%. You can see its size reduced by half. Now we can change the infill over here. So I'll just keep it at 10%. All the printer settings can be set over here. Like the layer height is now set at 0.3 millimeters. It can go down to 0.15 in this printer, and the filament is 1.75 millimeters, and the extrusion multiplier is set at 0.98, and this is just the shape of the bed. So the print is now centered and can be sliced. This is what the sliced result looks like. So as you can see, the layer lines are visible, and you can see what exactly the infill is and how the printer behaves. So this will simulate like you can see the head is moving around here. So this is how the actual printer head will move on the build platform. So now you can just directly export it to the SD card right over here, and you can eject it.
The printer also has an inbuilt power loss recovery feature which can be accessed through this menu, as you can see. So if I just put off the power right now and then just restart it, so it should give me an option to resume power loss printing. So as you can see, either I can stop the print or I can resume the print. If I click on resume and move the head a bit so that it does not indent the print there, the head will heat up right now. So let's wait for it to do that. So the head is almost heated up. As you can see, the print is halfway done and the power loss recovery feature is now in place. The printer will home itself and start back from the layer where it stopped. As you can see, it started again. So that was a power loss recovery feature. Also, there is this ESP32 which I'm using. This used as a Wi-Fi module on the Arduino. It communicates on UART, and this has a pontoface like interface. Basically, it runs a web server on it which you can access through a Wi-Fi access point which this generates, and it can control the printer over Wi-Fi. You can transfer files and home the printer, and it even has a camera function, but it is not present on this board, but it is attachment which can be put on this printer. As for the application of 3D printing, as you can see, this is a RC plane which I built. This is entirely 3D printed. So you can see this, the orange PLA which I used. All these this plane was entirely made in sections, which have been glued together. So these are the wing sections, as you can see. So this entire plane has been made only using 3D printed parts. Even the fuselage was made using 3D printed parts. And this is what the infill looks like. This drone arm. As you can see, this is the infill pattern. This is a triangular infill at 25%. So this is what the infill pattern looks like. And this is the drone which has been 3D printed. As you can see, this was the arm which I just showed you. So that's the application of the 3D printer. So other than the RC applications like the drone and the airplane, the printer can also be used to make replacement parts or prototypes for models as such in rapid prototyping. An example of rapid prototyping can be seen in the printer itself. As you can see, this part was not the original one. The original one was this one, printed in white. Actually, this part was actually slightly misaligned. So you can see this was causing a bit of Z wobble to come into the prints. So the new part was printed and it has completely eliminated Z wobble right now. So that is another example of rapid prototyping here. So all in all, the printer has achieved all its required objectives and is now a perfectly working printer, as you can see. So that's it for my final review 3 for mechatronics project of winter semester 2021.